Hey guys, welcome to this video. Today we'll talk about a very interesting topic, that is Kotlin Symbol Processing. Before that, let me introduce myself. I am Palash Dumbre. I'm a software engineer at Globant and I hold around 6.5 years of experience into mobile application development. Please do like and subscribe for more such videos. And if you want to contribute to this MeetKotlin community, please do reach out to us on the email given in the description. So let's get started with Kotlin symbol processing. KSP is a new meta programming tool. As you might aware, meta programs have the ability to read other programs, generate codes, and return a modified program. You can think of any auto-generated codes like Dagger or Room generates to understand about metaprogramming. KSP creates lightweight compiler plugins which compiles the source code, and you can add the ability to generate codes at compile time, maybe to reduce boilerplate codes and speed up development. Why to use it? It reduces overhead of manually writing boilerplate codes to speed up development and get rid of writing similar repeated stuffs. KSP is not tied to JVM, making it adaptable to more platforms. Thereby, we can achieve code reusability in multi-platform projects. KSP also comes with increased build performance compared to KAPT. Also, this supports all Kotlin specific features such as top level functions, etc. I'll be showing a practical demo of KSP using Android Studio. So let's quickly move to Android Studio. To get started with KSP, you need to add two modules. You can add those modules as a Java library. They are annotation and the processor. You already have an app module. Let's start with the annotation module. You can see that in this annotation module we have a build.gradle file. Please note that this build.gradle file is a .kts file. That means it's a Kotlin script. In this script we have to add a plugin. So let's add the plugin. Let's add a class decorator which will have the annotation which will be used by the interface. So we'll just add a annotation which is a decorator where the retention will be the source and the target will be the class, as we'll be using this on the interface. And we are done with the annotation module. Now we'll work on the processor module. We have a build.gradle.kts file. Let's add the plugin. We have Kotlin, then we have the KSP plugin which will specify the version. We'll need some dependencies. Let's add the annotation as a dependency which we have added as a module in our project. Then let's add KSP symbol processing dependency. Finally, let's add the Kotlin poet dependency which will help to generate the codes. Next, let's write some code. We'll go to the source Java and we have a decorator processor class, a class decorator processor which has a param code generator, and we need a parameter for debugging purpose. We need a logger which is a KSP logger. We'll inherit this class with symbol processor which we need to override the method process. Let's find all the classes which are using our annotation, which we have added in the annotations module. Let's wrap this in a let's scope. Let me rearrange this. Next, we'll filter it to check if the symbol is really a class and is validated. So let's use the filter method. Symbol.filter it is a case class declaration. and it.validate. Next, we need to go through each of these classes and even each methods in the classes. Hence, we need a visitor to do this. Next, we'll work on the visitor so that we can continue on class generation. So let's move to the visitor class. Create a class decorator visitor having parameter code generator and the next parameter KSP logger. We'll inherit this class with KS visitor void, which have several methods that are used when classes or methods are visited, and we can make use of that to generate codes. The method that will be called when the class is visited is visit class declaration. From here, we need to visit methods that are present in this class. So we make use of this get declared function, and to each of the function we'll call accept so that the respective visit methods will be called. From here, the visit function declaration will be called. Let's override the visit function declaration method. Here we know that the interface have this method, but to get complete information of this method we need to know about its return type as well. So from here we need to visit a method which can tell us about the return type of this function. To visit it, we need to call the accept method on the function's return type, and the method that will be called is visit type reference. Now we need to arrange all of this information, as we will need all of this information to generate our code. Let's simply create a data class which will store the function name and its return type. The return type will be a case type reference. Let's keep it a optional parameter and put a default value as null. We'll need a list of data class. Let's create it so that we can add all the functions inside this list. Now let's start adding the functions to the list. Here only name will be added in this method visit function declaration. Let's create the object of our data class and add the function name to it. As return type is optional, we don't add it here. We'll add it in the visit type reference. So let's go to the visit type reference. In type reference we need to find that function for which this type reference method is called, and we'll assign the return type to it. Let me do that. We are just checking that the function name which we have already added matches the type reference for which this method is called, and we'll just assign the return type. Now that we have all the information regarding the interface that uses our annotation, we can now generate the codes that we can use. Let's get the package name, then we'll get the class name. The class name will be same as the class declaration. Then let's create a file. We'll be creating first a file that will have a class. So let's create that file using file spec builder. We'll need to pass package name there and the class name, sorry, the file name, and using the apply function we'll add other properties to it. Let's use the add type. Then let's create a class using the type spec. We'll use a class builder. We'll passing class name there, and it has a primary constructor. We need to create a constructor using a constructor builder. Let's do that. And in constructor we know that we need a parameter. I'll just create a function to get the parameter to keep the code simple. This function will return the parameter spec. Let's create that function. Get constructor param. We'll pass the class declaration as well, make use of that. So let's return the parameter spec. Let's pass the name as class declaration, and the next parameter is a type name. So let's create a function for type name, as this type name will be used in many places going further. Let's create type name. Again we'll need class declaration. Let's create this function get type name. Let's return a class name from here. It needs a package name. And the file name. Let's get back to our main function where we are building our class. We need to build this. We'll add a dot build function. Next, we want that the parameter should be a val so that we can use it in functions. To do this, let's use property spec, which have a property name, and again we need the type name. We already have a function for it, get type name, so we'll use that. Then we want that it should be initialized. To do so, we need an initializer and the build method. It will add a public val to the parameter that we have added in the constructor. Then we want that our class should extend the interface that we will annotate. Let's do this using the add super interface. We'll add public and open modifiers to it. First let's add the super interface. To do this we will use the get type name, and then let's add this modifier. Let's use this key modifier dot open, and again we need a public modifier. Let's add that key modifier dot public, and then we'll add functions, as now we want all the functions that are in the interface to be implemented in this class. So let's add a new function, get all functions, passing class declaration and build method. Let's create that function get all function. We'll need a list of functions to store all the functions, the func specs, as the return type is. Let's create that. Now we'll loop through the all functions dot for each, and then we need to gather all the information that are in the functions like return type. Let's do it it dot return type, and we need as a type name, so let's convert it to type name. And you can see the error is about the Kotlin poet preview. As it's in preview, we need to add a annotation to our function. Then let's find the class name, sorry, the param name, which is in the function. And then we can add the func specs into this list. Let's create that in the add function, funcspec.builder. Then let's add that function name. We need to add modifiers. This all will make sense when you will see the auto generated classes, and you can visualize it how the class is generated, and then you can correlate things, so don't worry about that. So the last statement will be a return param name. It will be a function, so let's add a double bracket as well, and the build method, and our get all function is ready. We'll just return the list of function. Finally, we need to write this everything we did into a file. So using this file spec dot write to, using the code generator, we can do that. So again, we need this preview, so better to add it in a class level. So we have added it on a class level, so now we don't need on an individual function. And this decorator visitor class is now ready. Now let's get back to our processor to connect the things. uh, we have developed a decorator visitor, so we need to connect all of this. So let's add it.accept. We need to pass the visitor, that is decorator visitor, code generator, and the logger. Here in this for each loop will be getting all the interfaces which are using our annotations. And finally, from this function process, we need to return all that were not validated. So let's do that. And if it's empty, we'll return just empty list. Who is responsible to call this processor? Here the symbol processor provider comes into picture. Let's create it quickly. This class will inherit from the symbol processor provider, and will implement the create method and just return the provider from here. And this provider has to be added in a class, or I can say a file, which will be present inside a resource bundle. So let's do that. Let's add a directory in the resource bundle. Let's say it's meta.inf, meta-inf, and again a directory inside it, services. Then let's create a file inside this. The file name is very important here. It should be com.google.devtools.ksp.processing.symbol processor provider, and let's create it. And you need to add the path to your provider here, which is com.example.processor.processor provider. As we have completed the processor and the annotation module, let's move to the Android module. So let's move to the Android build.gradle app level file. Let's add the plugin, KSP plugin, specifying the version. Let's add processor and the annotation module as a dependency, and let's sync it. Till the time, let's go to our accessories to create an interface of accessories. So the code will be generated for this interface. Most important part, we have to annotate this interface with our annotation. Let's build it, and you can see that there is an error saying redeclaration of accessories, but you can see that the code is generated, and you can see that the accessories and the interface have the same name. That's why the error is. So we need to change the name. So let's move to the our visitor, which was responsible to give the name to this class. So here, let's change the class name to decorate with and the interface. So every time the code is generated, the class name will be like this, decorate with and the interface, as you can see, and the build is successful. And here we go, congratulations, you have auto generated a class using an annotation. Now let's close all the tabs and let's focus on the Android part. But you will not see any Android app here. Just I'll show you how to use that in the Android app and the console only. So let's create a variable car, and we'll use our auto generated class, that is decorate with accessories, music system, and passing the car. And we'll add a log there, log.d, and we'll just add a slash n to view the output properly, and car.get description. And after running, you can see that we got this output, and yes, we are done. So I hope now the KSP is very clear to you, and you can create your own auto generated classes using KSP and use it wherever needed. Thank you.